All right, welcome. As you remember, or you may remember, when we left off on Wednesdays, we finished up this coding for the unfair coin toss. And now there's two more topics left in chapter 4 that I want to cover. And so our first topic is going to be just this idea. When we're looking at equality, there's an equals equals symbol that we've been using, and it's going to work in most cases. But there's also this object method that we're going to use, which is the dot equals method. And I just want to show you where this comes up and why we would use this. So it's a little bit of a side topic, but it's going to be okay. All right, so I've got this code here, and you can kind of see here I've got an int, n1 is 7, n2 is 8, n3 is 7, and just to make it slightly interesting, we've got a double, and d1 is 7.00. All right, so we can use our equals, and we're going to check, does n1 equal n2? And let's see, n1 is 7, n2 is 8. And so we're kind of thinking that should be false. And if you notice down here, I ran it already and I left my answers there, my bad. But that's okay. Or here, if I have n1 equal n3, seems like that should come out to be true. And then the double we haven't talked too much about, but if we have n1 is 7 and the double is 7.00, looks like hopefully that should come out to be true too. So let's just run it again and make sure those are actually valid results. And hey, we are good with that. All right, so that part is all clear, it makes sense, kind of what you expected. All right, then we're going to come over here and we'll look at this question here, and it's going to be very, very similar. But here what we're going to do is we're taking two strings. So our first string we're going to store in word 1. All right, and our second string we're going to store in a variable word 2. Oops, and then I got to change this, my bad. Got ahead of myself. And we're going to use equal, because word 1 equal word 2. All right, so let's try this and see. Let's save this, Control S. Got it saved. Let's run it. So down here, my first word is going to be hello. And my next word is going to be hello. And so in word 1, I've stored hello. In word 2, I've stored hello. And now I'm going to try this equals and see, does word 1 equal word 2? And it seems like they should equal each other. So we're going to hit enter down here. And they do not come out to be the same. And so this will be an issue, not just with strings, but this will be an issue with every object. We haven't created a lot of objects yet, but as we create objects, this is going to be an issue with every object that we create. This equals method is not going to behave the way that you intuitively think it's going to behave. So what I'd like to do is just explain to you why. Long story short, we're going to use this other method called equals. But what I'd like to do is just understand why this is happening, why it's working the way it's working, and then we will resolve the situation. All right. So we take a look here at our notes with the integers. Equals is fine. No issues there. And as soon as we bring in these strings, the equals is not working the way we think it should be. So that equals, we can kind of say it's problematic. So we had hello, and we got a false on that. So that's not what we wanted. Okay, so here's the why behind it. And like I say, this is just background information, and we will resolve it here. And the reason is, when your code runs, it's stored, your variables are stored in two different places. There's the stack, which is kind of the immediate memory, and then other things are stored a little further away. It's all in the same RAM, but other things are a little slightly more remotely. They're in the heap. Okay, so your stack memory is for anything that's a fixed size, and in Java, all of our primitives are fixed size. An int, remember, is 4 bytes. A double is 8 bytes. A Boolean is 1 byte. So all these things have a fixed size. So any primitive is stored in the stack. All right? But if you have a string or any other object, we don't know how big it's going to be, because a string could be 2 letters. It could be 100 letters. It could be the grapes of wrath. It could be huge. We don't know how big it's going to be. And so any Java object, it's not stored directly in the stack. Instead, it's stored in the heap. this little more remote storage, which is more flexible in size. Whereas a stack, it's like, we know 4 bytes for this, 8 bytes for this, 4 bytes for this. Whereas a heap, it's like, we don't know how much memory, but this object takes up 100 bytes. This object takes up 5 bytes. And that's kind of what the heap is for. It's more flexible, but it's also slightly more remote. So anyway, objects like strings are stored in the heap. And then in the stack, what it's done, it just holds the address to where the object is in the heap, okay? But the actual value of the string is stored in the heap. And so what's going to happen is this equals equals is only going to look at the stack. It never looks at the heap. All right, so if we come back to our ints, these are primitives. They're all stored in, the double is also primitive. They're all stored in the stack. So we've got this variable n1, the value 7 is stored in the stack. N2, 8 is stored in the stack. N3, 7 is stored in the stack. D1, 7.000 is stored in the stack. When we call the equals equals method, it looks right here and says, hey, does 7 equal 8? Nope, false. Does 7 equal 7? Yes, true. Does 7 equal 7.000? No, I'm sorry, that's a yes. Yes, that's a true. And so that's what equals equal is doing. It goes into your stack memory, it looks at the variables and checks, are they the same? All right. So now we get to these objects, we get to these strings. So what happens in the stack is we've got a variable word1 and a variable word2. We've got those, but they're objects. So the stack doesn't store the value directly. Instead, it has an address somewhere over in the heap. So we had the heap address 1, and now we come to the heap memory, and there's address 1, and over here it stores hello. And we have word 2. Where's that stored? Over in the heap. So we have heap address 2. We come over there stored hello. But when we check the equals equals, it looks here in the memory. It looks in the stack in the memory, and it sees, oh, look, here's address 1. Here's address 2. They're different addresses, so it returns a false. And this is going to be true for every single Java object. So it's kind of this idea we're going to talk about later, be passed by value. I'm sorry, passed by address and passed by value. Primitives are by value. Objects are by address. So just these addresses are stored in here instead of the whole value in here. So what happens is when you create an object, you can also write this equals method. Okay, and what that will typically do, it depends how you write it, but if you write it correctly, that will look in the heap, and it will look at the characteristics of the object in the heap and say, oh, look, that's hello, and that one's hello. So it'll go over into the heap and verify the equality. And so the equals equals is what you want to call for any object starting with strings. All right, so long story short, if you got primitives, equals equals is your only option. So if you want to check the two primitives, ints and doubles, whatever, equals equals, that's your only choice you could do. If you've got a string, you could check with an equals equals, but you don't want that. That's not really going to be your default. Instead, you want to use this dot equals. All right, so let's bring this code back over here for a second. And so my claim is here in my code, since these are strings, I don't want to use equals equals, I want to use dot equals, and you can kind of see it's there. And my second object is word2. And then what the equals, this dot equals will do is it will check the values in the heap. And are the values the same in the heap? All right, Control S, save this. Let's run this. And just for consistency, we're going to type in hello and hello again. Hello. Hello. Oops. Hello. And now the dot equals gives us the value we want. So, long story short, primitives equals equals works just exactly as expect. Strings, other objects, you're going to want to use this dot equals method for the objects. All right, that's our first topic here. And so again, here we'll show that same thing here, but that will take care of our first topic. So strings, and then as we go further into this, any other objects, use the dot equals method. Do not use equals equals. All right, I think we will pause it here. We'll have a second video